Swayam Prabha. Digital India. Educated India.
So what is dES by dt from this? K1 concentration of E into concentration of S minus K minus 1 plus K2 into concentration of, right? So if you basically K1 into concentration of S, so basically there are three steps, right? For ES, formation of ES, disappearance of ES, disappearance of ES, right? So there are three steps. So now if you do this, what will be my, so this is equals to 0. If you apply steady state approximation, this will be equals to 0, right? So concentration of ES is equals to K1 by K minus 1 plus K2, K1 by K minus 1 plus K2 into concentration of S. So this is my concentration of ES, right? So this is, now I am defining this part as a new, so I am defining something called Km, which is Michaelis-Menten constant, K minus 1 plus K2 by K1. I will talk more in detail about Michaelis-Menten constant, but I am just making, to make my life easy, I am saying that K minus 1 plus K2 by K1, I am calling it as Km, okay, which is called Michaelis-Menten constant. What will be the units of Michaelis-Menten constant? Units. What will be the units of Michaelis-Menten constant? Rate of the reaction is K2 into ES. So if I just put it this, K2 by Km concentration of E into concentration of S, right? I'll further derive it, but what are the units of Michaelis-Menten constant? M. How do you know that? The units will depend on concentration. So from this, can you define what will be units of M? If I write this ES is equals to concentration of E into S by Km, right? If I define this as Km, this will be by Km. So what will be my Km? Right? This is concentration into concentration by concentration. So what will be the units? The units will be molar. So right, so it will be basically molar, which is concentration units. So if it is molar, then what do you infer from this? So this is the order of a reaction. This is a rate constant. These two are rate constants. If Km should have a M, right? If it needs to have a if it needs to have a unit of M. So if both are first order reactions, suppose, what are the units of first order reaction? Second inverse. So if both are second inverse, it is not possible to have, right? So only if one of them is basically, so what is the order of zero order reaction? What will be the order of the what will be the units of rate constant of a zero order reaction? Mole. So molar inverse, right? Mole per liter, that is nothing but molar, right? Mole per liter inverse per second, this is nothing but molar per second inverse, right? So if this has to have a unit of this, these two will have molar into second inverse and this will have a second inverse, right? That means these two should be zero order reactions and this has to be a first order reaction, only then that is possible. So that means within the same reaction that we wrote, E plus S is in equilibrium with ES going to P plus E, K1, K minus 1 and K2. Looks like this has basically a first order reaction, these two are zero order reactions. So only then you will have the unit of concentration of M, right? So you have a rate of reaction is K2 by M into K0. So from this we will try to determine. So if you, I will not do the derivation, you must have done the derivation and other things. So I will write the final expression, mu is equals to K2 E0 into substrate concentration by Km plus S. Okay. So if you want, you do it as a homework where you basically E0 is equals to E plus ES, right? So your ES is equals to E0 minus E. So you can substitute it here, or basically E is equals to E0 minus ES, sorry. E is equals to E0 minus ES. So you can substitute it here and do a simple mathematics, okay? That I am not going to do the derivation. Okay, you do the derivation, you will end up with this expression. Nu is equals to K2 E0 into S by Km plus S. This is called as Michaelis-Menten equation. And this is what is this nu? And anybody has questions in how we got this derivation? So I have told you this. Now in this you substitute this one, okay, and do a simple mathematics. You will get this expression because the rate of reaction is K2 into ES, right? So what is this? What is nu? Velocity. What did I write here? But is it a rate of a reaction or is any specific term that has to be used? What is it? To start with, I have told you one thing. We have made an assumption, right? What is the assumption? No, steady state approximation is there, but initially we removed the backward reaction of ES going to P, right? Only that will happen when the product concentration is very low. So this is not called simple rate, this is called initial rate, only in the initial condition. So enzyme kinetics is whatever you are doing in the Michaelis-Menten kinetics is initial rate. Initial rate is equals to K2 into E0 into S plus Km plus S, okay. Now, but this is all fine, right? We got an expression, we understood this. But how does this expression show you different orders of the reaction when the reaction is going? So take two examples. Can you determine when the substrate concentration is very low, when the substrate concentration is very high? Under these two conditions, can you tell me what is the order of the reaction? So this is the expression when the substrate concentration is very low. That means your substrate concentration is very low compared to Km and substrate concentration is very high compared to Km. What will be the order of the reaction under these two conditions? Where is zero order coming? So first one, by the way, you all understood what is this, right? Km, what are the units of Km? It is having a unit of concentration, right? Right? So this is also concentration, this is also concentration. So when substrate concentration is very low, that means if substrate concentration is much lower than Km, what will this happen to? What order it will become? It will become a first order reaction because if S is very less compared to Km, you can ignore this, right? Then it will be K2 E0 into S by Km. Now K2 is a constant, E0 is a constant to start because it's an initial enzyme concentration, Km is a Michaelis-Menten constant. So all these are constants. So mu is proportional to concentration of S. So what is the order of the reaction? So if I plot mu versus substrate concentration, at a very low substrate concentration, it will be first order. First order means how will be the line look like? Okay, something like this. Now at a very high concentrations, if concentration of substrate is very high compared to Km, what will be the order of the reaction? So if the substrate is very high, you can ignore this, right? These two get cancelled. Mu is equals to K2 E0. So there is no substrate dependence at all in this, right? So this will be 0 at a very high substrate concentration, will be 0 order, right? 0 order means the rate of the reaction is independent. But there are intermediate concentrations. When S at intermediate concentrations, you will have a fractional order. So you will have so this is a first order reaction, this is a 0 order reaction, and this will be a fractional order. It will be somewhere between 0 and 1, okay, depending on the substrate constant. That means for the same reaction, the rate of the reaction is going to alter. Anyhow, rate of the reaction will alter with substrate, but the rate of the reaction will alter with substrate only in the initial phases, where it will have first order, then it will have a fractional order, and then it will have a 0 order reaction. Okay. Now you see this. Now so the rate of the reaction is increasing with the substrate concentration. For a large part, the rate of the reaction is increasing the substrate concentration, right? After this, no matter how much you increase the substrate concentration, the rate is not increasing. This is called as, what is this called? So initially your rate is increasing with the substrate. So generally if you want to increase the rate of reaction, how do you increase the rate of reaction? You increase the temperature, you increase the pressure, you increase the substrate concentration if it is not a 0. So you increase the substrate concentration, the rate is increasing. But at a certain time, after a certain time, it becomes a 0 order reaction. If it becomes a 0 order reaction means no matter how much you change the substrate, the reaction, the order of the reaction, the rate of the reaction is not going to change. So this is called a maximal rate. Okay, this is called maximal rate. So mu is equals to Vmax. This K2E0 is there, no? This is called max. So no matter how much you increase the substrate concentration, for a specific enzyme concentration, this is the maximum the rate can go. Okay, so in some textbooks you will see this as mu is equals to Vmax into S by Km plus S. So in some books you see like this, in other books you see the other way. Okay, now let us try to understand the physical meaning of this. We did maths for last few minutes, that's fine. So you have two expressions, right? So what is this curve like? This is Ax plus B plus x. What is y equals to Ax plus B plus x? What is this mathematical expression? Right? This is a constant, so I am writing Ax plus B plus x equals to y. Y equals to Ax plus B, Ax by B plus x. What is this mathematical, what kind of function is this? Y equal to mx plus c is linear, but this is more complex, no? Ax by B plus x. Parabola will have have you seen this expression anytime in maths? Y equals to Ax plus by B plus x. This is called rectangular hyperbola. You all know what is hyperbola? This is called rectangular hyperbola. A rectangular hyperbola will have something like this, right? Y and x. So that is why you have y equals to, so this will have a rectangular hyperbola kind of. So this is the mathematical expression, mu is equals to Vmax into S by Km plus x. Okay. Now let us understand the physical meaning of these two. So you know what is rate of the reaction? The substrate concentration can be S0. What is Vmax? Vmax is maximal rate that the reaction go through. What is Km? Okay, but what information does it give? Michaelis Menten constant, but physically what is the information it is giving? Vmax means we are telling that that is the maximum rate the reaction will go through. Beyond that the reaction will not go. Okay. So what is Km? Km definition, you are calling it a Michaelis Menten constant, and how are we defining Km? Km is equals to overall rate of the reaction, K minus 1 plus K2 by K1, right? Now what is the physical meaning of Km? Okay, let me put it. Suppose if my Km is equals to substrate concentration. If Km is equals to substrate concentration, what will be the rate of the reaction? So we did two different things. No, if substrate concentration is very less, substrate concentration is very high. Suppose if my substrate concentration is equals to Km, what will be the rate of the reaction? Do the maths. Half max, right? If substrate if S is equals to Km, if S equals to Km, this will become 2S, right? 2S, SS cancel, K2 E naught by 2. K2 E naught is Vmax, right? Vmax by 2. So Km is nothing but, if you have a Vmax, this is the Vmax. So the half the substrate concentration at which the rate is, so this will be your Km. So if you know the value of Km, what it will tell you is, it will tell you the concentration at which the rate of the reaction is half the maximal rate. Okay, so if Km is equals to S, so basically this is the expression. So if S equals to Km, then you have mu is equals to Vmax by 2. So physiological or physical, what is the significance of Km? Km means it is the concentration of the substrate at which the rate of the reaction is half the maximal rate. That means if you know the Km for a reaction, for the reaction to be faster, you should always use a substrate concentration much beyond the Km value. Okay, so Km is going to give you only half maximal rate. So if the substrate concentration is Km, then it is going to give you half the maximal rate, which is Vmax by 2. Okay, and is there any other physical significance for this? From that expression, can you see what is Km? So what is Km giving you more? What is this called? E into S by Es for this equilibrium? Association constant for Es formation, right? Right? So Km is nothing but the association constant of Es formation. It is nothing but, Km is nothing but, it is going to give you the association constant of Es formation. Now should for a reaction to be efficient, should Km be high or should Km be low? Okay, I will repeat myself again. So Km is telling you the association constant, right? Or it is not association constant, sorry. So it is basically giving you Es by Es, right? So for a reaction to be efficient, your Km should be high or Km should be low. That means when the Km is high, the Es complex will form better or faster, or when the Km is low, the Es complex will form better. You want this to be high or this to be high? Es should be high. For a reaction to be better, this should be higher, no? So that is Km should be? So a lower Km is always better than a higher Km. So if you want to compare two enzymatic reactions, a reaction with a lower Km is always better than a higher Km. And you will be surprised to know that the Kms for most of the enzymatic reactions are in micromole range. Okay, for large reactions, Km will be in micromole range. Okay. Okay, so this basically what you have understood, or what I have told you, is what is the meaning, physiological meaning of Km, what is the physical meaning of Km, physical meaning of Vmax, And how does the order of a reaction? So what is the order, how does order of the reaction change with the substrate concentration, or rate of the reaction change with the substrate concentration? Now with respect to substrate, it is a first order at lower substrate concentration and a zero order at higher substrate concentration. Now with respect to enzyme, with respect to enzyme, is it a first order, or with respect to substrate it can have multiple orders. Low substrate will be first order, intermediate substrate fractional order, high substrate zero order. But with respect to enzyme, first order. How do you know? You are right, but how do you know? From all these expressions, did you find anywhere that the enzyme is directly proportional to the enzyme? How is rate proportional to enzyme? We have derived so many expressions, no? Your rate of a reaction is directly proportional to the E naught, right? If you are keeping your substrate concentration and everything constant, it is directly proportional. So it should be a first order reaction, right? Now can you draw a simple diagram or curve? Okay, now this is some E1. Now if I have a different, if I have the same enzyme where I have the concentration E2 greater than E1, so how will the curve look like on this? So till now what we did is we have changed the substrate concentration, right? You all remember there is an enzyme, there is substrate. We have only focused on substrate. When you change the substrate, at low substrate first order, at high substrate zero order, and then you have intermediate order. But now I am telling if I concentrate on the enzyme part, right? I just showed you that the enzyme is first order reaction, right? With respect to the enzyme, it is always first order reaction. Now if I have a Michaelis-Menten curve like this, and if I have an enzyme which is E2, which is greater than E1, how will the curve look like on this? Will my Vmax change? By the way, what is Vmax in this curve? Let me again pull. What is Vmax in this curve? This is the Vmax. What is Km? Half the Vmax, right? Now if I have an enzyme E2 greater than E1, how will the curve look like? Is my Vmax going to change or no? Increase or decrease? Okay. Is my Km going to change or no? It will change? How do you think it will change? How is it changing? So you have seen that nu is equals to, so Vmax, this one, right? Nu is equals to V. So Vmax is K2 into E naught. So if you are increasing the E naught, your Vmax will change, right? It will increase. But Km is nothing but E into S by E naught by S. So this is changing, but this along with that, this ratio is going to not going to change. So this Km is not going to change. So if you increase that enzyme concentration, your Km will not going to change, but your Vmax is going to change. Okay. So at a 50%, so at 50% Vmax, at 50% Vmax, because this will be your new one. So the Vmax by 2 will change, but the enzyme with the increasing the enzyme concentration, your Vmax will change, but the Km is not going to change. So that is how the curve will look like. Okay. So I'll just show you some numbers for you to appreciate the Km values. Okay. Tell the. So is the Km is not dependent on E naught directly. It is proportional to E and Es. So when you are changing the E naught, both E will change and Es will change proportionately because you have the same equilibrium. So if you see the Km is proportional to E and also proportional to Es. So E will also increase, Es will also increase. So basically because of that the ratio will remain the same. So your Km is going to remain constant. So is this a linear curve or a non-linear curve? Okay. So non-linear curves, if you are doing experiments, fitting a non-linear curve is very difficult, right? You have to use softwares like, or you have to use Origin, you have to use Excel, those kind of things, and then you have to do that. Can we convert this non-linear equation into linear equation? Can you convert this this is a non-linear equation, no? Hyperbola, rectangular hyperbola, ax by b plus x. Can you convert this non-linear equation into a linear equation? Because linear equations are easy to deal with, right? A non-linear equation will need a fitting, right? So from if you want, so in an experiment, what is it that you are varying in a normal experiment? If you are doing an enzyme catalysis experiment, you are determining what? You are determining the rate of the reaction, right? And what are you changing? Concentration of? So you are changing this and determining this, right? And from that you can determine the parameters Vmax and Km. But for that you have to fit it to a non-linear curve. But can you make it in a simpler way or can you make it into a linear curve? Take a reciprocal and see. You know what is reciprocal, right? Take a reciprocal and see if you can make it a linear curve. This, by the way, this is called Michaelis-Menten equation. I told you, right? This is Michaelis-Menten equation. Take a reciprocal and tell me how can you make it a linear curve or not. If I take a simple reciprocal, it will be 1 by nu is equals to Km plus S by Vmax plus S, which is nothing but, sorry, Vmax into S. It is nothing but Km by Vmax into 1 by concentration of S plus 1 by Vmax. Now, does this look like a linear curve? What will be my y-axis? Y-axis 1 by nu. What will be my x-axis? 1 by? So instead of taking nu and s, if I take a 1 by nu and 1 by s, so this is 1 by nu, 1 by s, right? So this is x, and instead of taking nu and s, I will take a reciprocal of that, 1 by nu and 1 by s. So y is equals to mx plus c, right? This is a linear curve. So what will be, so this will be a linear curve like this. What will be the slope of this line? Huh? Slope Km by Vmax, right? And what will be the intercept? This intercept is 1 by, this is mx plus c, right? So this is the slope, that is the intercept. So we have converted a non-linear equation into a linear equation by just doing a reciprocal of that. So this is a much easier, so if you have to calculate Vmax and Km from this, then you have to calculate the rate of a reaction at different concentrations and fit it to a non-linear hyperbola, rectangular hyperbola, and whatever is the fitting here. But instead of that, you would do the reaction, you have the substrate concentration, you have the rate of the reaction, but instead of plotting nu and s, you plot 1 by nu and 1 by s, then you will get a linear curve where the slope of the reaction is Km and the intercept is 1 by Vmax. This is called as Lineweaver-Burke plot. Have you heard of this? This is called Lineweaver-Burke plot. Okay, it's called Lineweaver-Burke plot. So if I have to determine the Vmax, how do I determine the Vmax? if I have to determine the Vmax, how do I determine the Vmax from this? Inverse of slope. Inverse of intercept. Inverse of intercept, right? And if I have to determine Km, how do I determine Km? If I have to determine the Km, how do I determine Km? Slope by intercept. If you take slope by intercept, what is slope? Km by Vmax by intercept 1 by Vmax. Vmax will get cancelled, on Km will remain, right? So if I have to determine your Km, Km is equals to slope by intercept. And if I have to determine Vmax, it will be 1 by intercept. So for a specific reaction, so if you want to understand the enzyme kinetics, you always need to know two parameters. What is the Km of the reaction for that reaction? What is the Vmax of that reaction? Km should always be low or high. Km should always be, for an efficient reaction, Km should always be low and Vmax should always be high, right? Because rate of the reaction is a maximal rate. So the for an efficient enzymatic reaction, Km should be low, Vmax should be high. So if you want to compare various enzymatic reactions, you can compare various enzymatic reactions by determining Km and Vmax. So just by doing a simple experiment of determining the rate of reaction at different substrate concentration, just like how you do in your lab, you calculate that and then you plot that, you can determine both Km by Km and Vmax from this expression. But is there any issue with this expression? With this plot 1 by nu by 1 by s, is there any limitation? Do you find any limitation with this one? The other one is non-linear, so you will have to use fitting, but for this do you have any limitation? So if you see 1 by s, if you want to touch this intercept, right, 1 by s means what should be the substrate concentration? It should, no, so for this to touch 0, what should be my substrate concentration? If this has to touch 0, what should be my substrate concentration? It should be infinity, only 1 by infinity is 0, right? So that means when you do the reaction, you do a reaction at a very low substrate concentration, means you are doing here. You are doing the reaction here, you are measuring everything here and then you are extrapolating everything to this part. Because it is impossible to do the reaction in this region, because you need to have a very high substrate concentrations, right? So the substrate concentrations that generally work, which are micromolar and millimolar, are here. So you only do the reaction here and then you extrapolate it here. So the errors are slightly higher than the fitting. So that is a better way because you are fitting it, whereas here easier way, but here the error is more because you are doing, or your points are here but you are extrapolating it to here. Okay, extrapolations will always have a higher error than direct fitting. So that is why this has that issue, but you need not worry about it at this point. But I want you to take a quick look at these things. Okay, so for you to understand an enzyme catalyzed reaction, you need to know what is Vmax, which has to be very high. You need to know Km, which has to be low. But in addition to that, you can also tell whether a reaction is good or not by using what is called TON, which is turnover number. Okay, so turnover number or Kcat is nothing but Vmax by E naught. So what is Vmax by E naught? What is the rate constant? Vmax by E naught is what? K2. So turnover number means how many molecules of enzyme, how many molecules are basically the number of substrates that are converted into product per enzyme molecule. So one enzyme is converting how many substrates to products, that is called turnover number or Kcat, or it's called K2, which is given by K2. And there is also other thing called catalytic efficiency. This is only telling you Vmax, right? But a reaction is not just governed by Vmax, it is governed by both Vmax and Km, both, right? So there is something called catalytic efficiency, which is nothing but Kcat by Km. So you need to have a low Km and high Kcat for it to be highly efficient. This is denoted by epsilon. So catalytic efficiency is Kcat by Km. So when you want to characterize an enzyme, you tell what is, so if you tell Vmax, if you tell Km and other things, every enzyme might have a different Vmax, different, so the Vmax will depend on the enzyme concentration or not? Vmax will depend on enzyme concentration or not? Vmax will depend, suppose now I have two enzymes, okay. I am comparing which enzyme is better. So I am comparing two enzymes, I am trying to understand which enzyme is better. Now if I just compare their Vmax, will it be okay? Vmax will depend on enzyme concentration or not? We just draw the group, we drew it, no, E2 greater than E1, when E2 is greater than E1, the Vmax is increasing. So you can, when you are comparing two enzymes, so you need to divide by enzyme concentration as well. So that is given by turnover number, so Vmax by E naught. But then that is only telling you Vmax, but it should, Km is also something important, no? How fast the enzyme is recognizing the substrate, that is also important. So the enzyme kinetics depends on two things: how fast the substrate is binding to the enzyme, which is basically the information is given by Km part. Once the substrate binds to the enzyme, how fast the enzyme is converting this substrate into product, that is given by Vmax. So now if you see this one, right, E plus S equilibrium with ES gives product plus enzyme. Now how fast this is happening can be done by Km, right, and how fast this reaction is can be done by turnover number or Kcat or K2, right. Now overall enzymes, if you are comparing both, right, if you are comparing two enzymes, it should have low Km and high Kcat, only then you can say this enzyme is better than that. For that only you use this term called catalytic efficiency. So if you are comparing two enzymes, whatever enzyme has a higher catalytic efficiency, that will be better, no matter what enzyme concentrations, what substrate concentrations, everything, because all of them have been normalized. So when you are comparing two enzymes, you should compare catalytic efficiency, which is basically Kcat by Km. Okay, we will quickly look at some of the numbers so that you can appreciate how efficient are these enzymes. Okay. Okay, so so turnover number is K2. What is catalytic efficiency? Km by Kcat, right? What is Kcat is K2. Km is K minus 1 plus K2 by, so I can write K1 here. So K1 K2 by K minus 1 plus K2, right? Now for a large number of reactions, this is actually negligible, K minus 1. That means this, for a reaction, for an enzyme to be very successful, the backward reaction should be slow, right? This K minus 1 should be negligible compared to the forward reaction. So you can neglect this. If you neglect that, that will become K1 K2 by K2, that is K1. So a catalytic efficiency is K1, which is nothing but diffusion controlled reaction. Okay, so the first one is diffusion, second one is activation. So we'll I'll tell you the numbers, just have a look at this. Turnover number, what is turnover number? K2, right? Basically the number of molecules or number of substrates that are converted into products by one enzyme. You are already dividing by enzyme concentration. So you can see carbonic anhydrase converts 6 lakh carbon dioxides into carbonic acids in 1 second. This is the enzyme. If there was no enzyme, how much time it was taking? It was taking 0.1, right? So, so you can see the enhancement in this, right? So you see all these enzymes. So penicillinase, it does 2000, it converts, or DNA polymerization enzyme that does that, it converts 15 substrates into products per second. So you can see the amount of enhancement that the enzymes are doing. So this, in this turnover number, you don't worry about the enzyme concentration because you are already saying per enzyme. Now, but this is not going to tell you about the Km part, which is the binding part, right? So if you want to see the binding part, so this is the catalytic efficiency. Catalytic efficiency is, so catalytic efficiency is basically Kcat by Km. So ultimate thing is catalytic efficiency because it will take into effect Vmax, or basically turnover number, and Km. So if you want to compare two enzymes, right? So you can see this is the catalytic efficiency, and which enzyme is most efficient? Crotonase. Okay, crotonase is highly efficient because it has a catalytic efficiency of 2.8 into 10 power 8. So we are not talking about Vmax or Km or anything. Everything is taken care of it in catalytic efficiency, which is Kcat by Km. So you can see carbonic anhydrase has 8.3 into 10 to the power of 7. Oh, sorry, there is superoxide dismutase also, which is 7 into 10 power 9. So superoxide dismutase is also a very, very important enzyme in your body. Okay, so this has a very, very high catalytic efficiency. That means it has a very low Km and very high Vmax. So if you want to compare different enzymes, this is the number that you need to use, which is called catalytic efficiency. Okay, so you can see how much, how efficient the enzymes are in converting a specific substrate into other product. If there was no enzyme, if there were no enzymes, the reactions would be slow, that actually the life would not progress at all. Okay, so, okay, now I'll stop it here, but I just want to tell you, we have neglected the backward reaction, right? From the beginning we ignored, but you can actually do the entire derivation by taking the backward reaction. If somebody is interested, do the derivation by, this is the backward reaction, K4, right? So I suggest you to consider that backward reaction as well as, and do the entire derivation, and you will see the entire, how nicely the Michaelis-Menten reaction changes. Okay, in the Michaelis-Menten you only took this part, but you neglected this, but if you consider that, this will be the overall reaction. So you will end up with the expression like this. You will end up with an expression like this. So it will also have a product concentration in this, because previously we thought product concentration is very, very low, so we neglected it, but we will also have a product concentration in this. So the expression changes completely. Okay, this is a little complicated derivation, but you can do it. Okay, so I'll stop it here, 12:53. So as just a quick reminder is, what we have done is, we understood why is important to study kinetics, why is enzyme kinetics important, right? How is enzyme kinetics different from a normal enzymes, okay? And then we quickly derived the mathematical expression for that, and we saw how at different substrate concentrations the order of the reaction changes, and what is the physical meaning of the parameters Vmax, Km, what is the physical meaning, what is it telling about a reaction. And if you want to compare two enzymes, you finally have to compare either turnover number or catalytic efficiency. So catalytic efficiency is the best way of comparing different enzymes. So we ended up with this overall understanding of enzyme kinetics. Okay, before I close, are you aware of any chemical or synthetic enzymes? All the enzymes that I showed you, all these are natural enzymes, right? You think, can a man make an enzyme and compete with the human enzymes or biological enzymes? So, we can stop it here.
SwayamPrabha, Digital India, Educated India.